A video of a future update to swLORETA that is inside of NeuroGuide by Applied Neuroscience. Ernesto Solera is working to add a rendered face to the to NeuroGuide and to swLORETA, and we can see that you can move through the volume. And now we'll have a face in swLORETA. You can use different slices to go through the volume, both horizontal, sagittal, and coronal. You can also go into the depths of the brain. Right now it's the depth, the deepest part, but we can move up to the top as we're going up to the top near the dura where it gets dark because there are no sources there. And we can just look at the axial plane, and these are z-scores actually at fairly low. We'll adjust them in a minute. We can look at the surface or just look at the slice from this point of view. We can also look at slices from other points of view. Here we are going through the volume again and rotating the head. But we can go through in a four view volume like this through the various planes and try to identify or just look at, for example, the left hemisphere or the right hemisphere. Or as we move through the coronal section, here we're going through the axial section up to the top with the controls in the upper right part of the display and swLORETA. We'll be able to look at Brodmann areas that are deviant from normal in different networks. There's a list of the Brodmann areas to the right that can be sorted by the z-score values or the number or left to right hemisphere. This will allow us also to eventually, as we complete this, and get better flexibility where we can look at both left and right hemisphere, and we'll have controls to do that. You can see here we're moving it around in 3 dimensions in terms of the volume. But with the skull completely rendered at the top, we can then project electrical potentials from the various electrodes. Like on this skull here, we can put electrodes or the electrical potentials generated by the sources inside the brain, and then look at segments and quadrants, left and right hemisphere, for example, with the sources that are being projected to the scalp surface. We'll be able to do that with the Fourier transform, but then in the future we'll be able to do this with the Hilbert transform and go time point by time point as far as the sources are concerned. So here you can see the sagittal and the axial view at the same time as we navigate through the rendered head. There's the eyeballs, and then evaluate which regions of the brain are maximally deviant from normal, and then get a complete picture because we'll be able to relate the sources inside the brain to the electrical potentials at the scalp surface. So what we're doing now is just testing out these various views and trying to perfect them, and to make this entire process user-friendly. This now is jumping to the volume by itself, and then we can look at the surface. Now there's the Brodmann areas that are outlined now in white, and now we can go to a network, for example, the addiction network, and the white Brodmann areas are shown for the addiction network, so you can see where the addiction network is, or the anxiety network, attention network, default network, autism disorders, executive function, language, memory, mirror neurons, etc. Each of them can be selected and then outlined in the rendered brain, and we'll be able to view those network nodes as hubs. Essentially, the Brodmann areas are hubs of a network that are connected to other hubs. Now here we put the volume back in and the surface of the view so you can evaluate the inverse solution. Now we're going down through the cortex and coming back up. That's one of the great things about swLORETA. It's a weighted swLORETA that allows you to go from the top surface to the depth of the cortex. Here we're going to move the scale for z-scores. Right now it's just at 1 hertz, but so that the z-scores there are at 2 standard deviations, and you can see which parts of the brain are deviant from normal. And then we can go down into the depth again and look at z-scores at the deeper surface of the cortex, as well as at the upper surface of the cortex. That's one of the advantages, as I mentioned, for the weighting that's available with swLORETA, because of the ability to create a homogeneous lead field in the inverse solution of Loretta. So these, just as a quick example of what we'll be doing in the future, this should be out in a week or two or so, and we'll be able to continue to advance Loretta, swLORETA,